Hi all, hope you all are doing good. From today onwards, we are going to see a lecture series on the subject Design and Analysis of Algorithm. Please note down the course code. It is 19 ITB 201. B represents blender, so it is a blended course. So first unit is Introduction to Algorithms. The second topic in DAA is fundamentals of algorithmic problem solving. So please note down the diagram carefully. The first step in the algorithmic problem solving is understand the problem. So first we have to understand the problem. Next, the step 2 is decide on computational means exact versus approximate problem solving algorithm design technique. So the third one is design an algorithm. Fourth one is prove the correctness. Fifth one is analyze the algorithm. The last one is code the algorithm. So we'll get to know about each and every step in detail in the upcoming video. So first step, understanding the problem. We have to understand the problem in a proper way. So what is the problem? What are the doubts in the problem? So what are the previous examples we have, and what are the use cases? So the input to the this step is instance of the problem. Second step, ascertaining the capabilities of a computational device. So we have computational device which can perform operations in a sequential manner and parallel manner. Sequential means we have to execute an instruction after an instruction. For example, uh, if we have 10 lines of code, the first line will be executed first, and after the completion of the first line, then we have to perform the second instruction in sequential algorithm. Next, in parallel algorithm, will be executing instructions parallelly, that means more than one at a time. So based on that, we'll be selecting whether we have to operate on sequential or parallel algorithm. Next, parameters, speed and memory of the computer system. This depends upon the application type. Next, choosing between the exact and problem solving. So for example, if we have two problems, for example, one is calculating the GCD of a number, and the next one is calculating the square root of the non-perfect number. Okay, for GCD we have to get a perfect number, which means we have to get the exact solution. So we'll be using the exact algorithm for that. In case calculating the square root of a number, just if we get a answer in a point, for example 3.142222, for example, in that case we'll be rounding off the answer. So in that type of problems, we are going to approximate the solution. So based on that, we'll be choosing between the exact algorithm or approximation algorithm. The fourth step is deciding on appropriate data structure. Next, we have to choose the appropriate data structure based on the problem. So next one, algorithm design techniques. So we have to choose the methods or process to solve a problem. For example, linear programming or binary search. So we'll be having several design techniques. So these are the common example to solve a problem. Okay, what do you mean by linear programming? We'll be processing it in a one word direction. For next, binary search. In binary search, we'll be dividing the problem into sub problems and we'll be processing. So the sixth step, methods to specifying an algorithm. So we'll be having three methods to specify an algorithm. One is natural language, which is understandable by the human beings easily. The second step is pseudocode. So it is a combination of natural language plus programming constructs. The third one is flowchart. So next one, proving an algorithm's correctness. Correctness is nothing but whether it works well and good for all the inputs and does not crash on giving the proper inputs. The next step is analyzing an algorithm. So at last we have to analyze whether our program or algorithm is time efficient, space efficient, it is simple and general. So time efficiency means uh, it is related to the time complexity. What is the time it takes to complete the execution of the whole program? The space efficiency, it is related to the space complexity, the space occupied by the program in the memory. So third one, it must be simpler, that is easier to understand and program. Fourth one is generality. Next, coding an algorithm. At last, after following these steps in a perfect manner, then only we have to code the algorithm.